Hello my dear students, I welcome you to NEET World. So today we will be discussing about electrochemistry. So particularly about electrochemical cells. So in the last class itself we have started about discussing about this electrochemical cells, right? Okay, so let us continue the same session here. So what we discussed in the last class, so we have discussed that electrochemical cells are those devices which converts chemical energy into electrical energy. Okay, so a spontaneous chemical reaction takes place in those cells, so that will be converted into electrical energy, right? This is what happens. Okay, so now yes, so before going to start today's session, I just want to announce you one thing. See here, we are going to launch this NEET long term course for NEET 2026. Okay, so it is at very affordable price and the batch starts from 1st July 2025. Okay, so 1st July it will be starting. Okay, so here you will be having the cost of this particular batch is around 3333, which is very affordable, right? Okay, so for more details you can contact our team to the mobile number which are scrolling on the screen. You can contact them, they will guide you complete further process. Okay, now not only JEE, not only NEET, will be also providing a new batch for JEE 2026. This is also long term batch for both mains level and also advanced level at this price 3333 and 4166. Okay, so these are what? These are the course fees per month. Okay, so for more detailed information you just contact. So here what we are providing in these batches. Okay, so we will be giving live plus offline batch, and it can be also in online also, you can listen. And you know, there will be every class will be recorded lecture of every class will be available in our app that is designed for most student friendly app. The name of that app is MedWorld. So where you can access our live lectures as well as recorded lectures and also lecture notes. Okay, and you can also have online exams also in that. Okay, so practice sessions will be provided. Okay, one-on-one mentorship will be provided, the doubt clarification should be there. Okay, so all these things will be there. And for those offline students, those who are willing to join for offline, so for you, if you are looking for hostel facility, yes, hostel facilities are also available with this particular course for these particular students. Okay, now let us discuss about today's session. Yeah, see, yesterday I have designed, I have given you the construction of these electrochemical cells and all. No? So let us discuss about this. See, we will be having two compartments. In one compartment oxidation takes place and other one reduction takes place, I told you. So in both compartments respective electrolytes and also the respective metal will be taken. Here for example, zinc sulfate or zinc nitrate solution is taken as electrolytic solution. So in that zinc rod is dipped. Okay, so that is connected to the another compartment through a wire. Okay, so this will be in this another compartment will be having like copper sulfate solution, copper nitrate solution with respective metal, that metal rod, that is copper rod dipped in it. Okay, so these two electrodes are connected through external circuit that we have seen in the last class also, right? So they are connected through some external wire where we have voltmeter to just check the voltage difference. Okay, and also we can have a switch also. Okay, so to connect them. Okay, now this is about external circuit. In this external circuit what happens, I told you. So this is the anode compartment now. So in anode compartment oxidation takes place, we have discussed. So here zinc rod will be converted into Zn plus 2. So it loses 2 electrons. These 2 electrons will flow from this anode compartment to from here to this side towards cathode compartment like this. Okay, so in cathode compartment what happens? So the copper plus 2 ions which is present in this electrolytic solution will take these 2 electrons and undergoes a reduction to form copper metal like this. Okay, so now what is net cell reaction? Here we have the cell reaction here I am saying. Okay, net reaction here I am saying. So what happens? See, reactant side, product side, we have 2 electrons, remove that. The net reaction you can write zinc plus copper plus 2 reacting to form Zn plus 2, okay, plus copper metal. So this is what forming here. So this is in the solid form, aqueous, this will be in the aqueous now, this will be in the solid. Hope it is clear. Now what is the cell representation for this? So I told you to write like this, cell representation, cell representation. So how can we represent? First write anode half, then represent salt bridge, then represent cathode half. Okay, so what is there in anode? So here zinc rod we have first, that is converting into Zn plus 2, undergoes oxidation. So here double slash, here single slash represents phase change. So for what is this phase? Phase change, or what exactly means here is, so zinc which is in having solid form, which is dipped in the aqueous zinc solution, that is what phase change or phase difference. So indicate that, I have indicated one single slash. Okay, so which is having a salt bridge here, U-shaped tube, so double slash I am representing. And here what we have, so copper plus 2 ions, okay, again copper plus 2 aqueous, again a phase change is there, so converting into solid form, so reduction. So this is a cell representation you need to do. Okay, first write anode half cell, then write this salt bridge, then write cathode half cell. Hope it is clear. Now what are the things to be taken in the salt bridge? A polysaccharide, something like agar powder will be boiled with electrolytes like KNO3, KCl or K2SO4, like this. Here they have taken KNO3, okay, or we can also take K2SO4, okay, or ammonium nitrate NH4NO3, like this. Okay, that will be taken in this salt bridge. Okay, that will be mixed with what? So agar mixed with these electrolytes, mean boiled with that, so that it will become a pasty mass. That pasty mass will be placed in this salt bridge, filled in this salt bridge. Now what is the use of this salt bridge? It will complete the internal circuit where electrons are flowing through this external circuit. Now electricity will flows, the current flows from this internal circuit through the ions of this salt bridge. Hope it is clear. And what is the uses of the salt bridge? So it will maintain the electrical neutrality in both compartments, as we studied in the yesterday's class. Okay, so both compartments, like sending this side anions, sending this side cations from this K plus and NO3. Nitrate ion will move to anode compartment, potassium ion moves to the cathode compartments. Therefore overall solution become neutralized. So for that purpose we will be using this KNO3 in this salt bridge. Hope it is clear. So why only KNO3? Because the mobility of ions, cation and the anion, mobility of potassium and nitrate ion are almost equal. The velocity of cation, potassium cation and this nitrate anion are almost equal. That's why it is preferred in this salt bridge. And we cannot use all the salts, like NaCl is not used, because the velocity or the mobility of Na plus and Cl are not much equal, but here these are equal, that's why they are preferred. I hope it is clear. Okay, that is the minimum criteria to be considered as a electrolyte to be taken in the salt bridge. Okay, then next what we have discussed, see here flow of current will be takes place when there is potential difference. Okay, so potential difference, how can we calculate here? So in order to understand this potential difference and how much potential difference is there here, we need to know electrode potential. So what do we mean by electrode potential here? So electrode potential is nothing but, see here we are zinc rod we are using in this zinc sulfate solution. Now here we have a redox couple, one is zinc converting into zinc, so zinc we have, and along with this its ion Zn plus 2. So this is what? A reduced form and oxidized form. So we can say this is a redox couple present in the anode. Same, another redox couple will be present in cathode, that is what? Copper plus 2 to copper, that is another redox couple here. Okay, so now each metal has its own tendency to lose the electron or gain the electron. Each metal will show it, or each species will have its own capacity or tendency to lose electron or to gain the electron, right? So that potential, that value will be given, that capacity will be given in terms of electrode potential. Okay, so if I wanted to say more reduction potential means what? The metal or that particular species has more tendency to undergo reduction. Okay, if I say more oxidation potential means that particular species has more tendency to undergo oxidation. Like this you need to understand. Okay, I will be showing you few more things here. See, I will be showing you one table here. See here, this is a table you need to understand. So how these values are came, how we calculated this, I will explain you. So just look here, fluorine molecule, see fluorine F2 gaining 2 electrons and becoming F minus. So it means what happening here? So F2 converting into F minus. So what is this process? Fluorine is gaining 2 electrons, right? So gain of electron is what? Reduction, right? So reduction. Here they have mentioned the value. So that value is nothing but reduction potential of this fluorine. So E naught standard reduction potential of this fluorine is how much? Fluorine is how much? It is plus 2.87. Okay, whereas for chlorine, if you observe here from the table, it is considered to be, it is found to be this much. So F minus. So for this E naught of Cl2 to Cl minus is how much? 1.36 positive. Now out of these two, which species, fluorine or chlorine, which is having more tendency to undergo reduction? So fluorine is having a greater value, so it has more tendency to undergo reduction. So what do we mean by this? So these values, this reduction potential value shows that which element or which species has more tendency to undergo reduction or oxidation. Okay, greater the reduction potential, see F2 is converting into F minus. So this symbolic representation is what? It is the reduction potential. Okay, it is the reduction, standard reduction potential value for this fluorine. Okay, now if it is represented like this, E naught of F minus to F2. So this is what? See, F minus is converting into F2. It means it is getting oxidized. Fluorine is getting oxidized, right? So here this should be called as oxidation potential. Now always remember, reduction potential and oxidation potential will be having same value with the opposite sign. The standard reduction potential and the standard oxidation potential will be having same value with the opposite sign. So here if you see, the reduction potential value is plus 2.87 I have written. So if I want to write oxidation potential for the same species, so what I should write? So minus 2.87 volt. Like this you need to write. Hope it is clear. Right? Now, greater the reduction potential value, the more tendency of that species to undergo reduction. So, out of these two, which is having more tendency, fluorine is having more tendency to undergo reduction. See, since it is undergoing reduction, it means it has tendency to gain the electron, right? So, since it is undergoing reduction, the species which is reacting with this will undergo oxidation. Now, since it is having stronger reduction potential value, more reduction potential value, it is considered as strong oxidizing agent. So out of this species which is strong oxidizing agent, so fluorine is considered to be strong oxidizing agent. Why I am saying it is a strong oxidizing agent? Because it is easily undergoing reduction and oxidizing others. So it is reduced and oxidizes others. So therefore this can be called as an agent which is oxidizes others, that is what? Oxidizing agent. Hope it is also clear, right? So which is out of this, which is stronger oxidizing agent? Fluorine. After that is cobalt, like this. Depending upon these values, you should give the order of their oxidizing power. Okay. So now if I wanted to write here for halogens, so tell me what is the order for the halogens? So I am giving you what is the order of F2, Cl2, Br2, I2 I have mentioned here. So which is strong oxidizing agent here? So what is your answer here? So it should be what? Fluorine, because it is having highest value. Okay, after that if you come through this table, here you have chlorine. So how much it is? Plus 1.36. After that if you come here, you have bromine, that is plus 1.09. So as we go down the group, values are reducing now. So it means the higher the value, more reduction potential it has, more easily it undergoes reduction, reduces itself and oxidizes others. The stronger reducing agent, oxidizing agent is fluorine, after that chlorine and iodine, and least bromine, and least is iodine. Hope it is clear. Yes. Li Neelam. See, yesterday we discussed this. Yeah, little more things to be discussed, ma. So just follow the class, so it will be clear. Okay. So I am discussing that things which are not discussed in the last class. Okay, just follow for some times. It will be gives you more clarity. Okay. So now, hope it is clear. And after this, I have one more sheet here. If you see out of this, from there to here, if you see, lithium is having more negative value. So reduction potential of lithium. See, E naught of Li to Li. See, Li plus to Li. See, plus 1 to 0 it is. So plus 1 to 0, it means what it is? Reduction potential value at standard condition. So standard conditions, E naught means what? This is the standard condition. That means temperature should be maintained as 298 Kelvin, or this can also be called as 25 degrees Celsius. Okay, and if it is metals or the aqueous forms, we can say, if we are taking aqueous forms, so it is 1 molar solution, we can say. And if it is gaseous substances, hydrogen, like that, so it should be 1 atm pressure maintained during this calculation. So it is found that the reduction potential is found that minus 3.05. Okay, it means this is having least reduction potential value. So it is having lithium is having least reduction potential value, and highest reduction potential value is for fluorine, right? So that is considered as, fluorine is considered as strong oxidizing agent. Now what I told you, how these oxidation potential and reduction potential are related to each other. So these are related, that oxidation potential is opposite of reduction potential. It means just they are different in the sign. So E naught oxidation will be equals to negative of E naught reduction. Okay, so here reduction value is how much? This much for lithium now. So oxidation value taken as, so minus of minus 3.05. So what we can say from here? So plus 3.05 volt is the oxidation potential of lithium. Now I can write this as Li converting into Li plus. So this indicates, see, Li converting into Li plus means what? This is undergoing oxidation, right? So this is the oxidation potential. So which is having more oxidation potential. So out of this table, oxidation potential is more for lithium. So I can say lithium easily undergoes, or having highest tendency to undergo oxidation itself and reduces others. Since lithium is reducing others, we should call lithium as strong reducing agent. So which is strong reducing agent? So lithium is a strong reducing agent out of all these series of species mentioned in the table. Okay, so they may give reduction potential value. So I can say more positive oxidation potential or more negative reduction potential indicates that it is a strong reducing agent, like lithium case. So this is lithium is like this, lithium is considered as strong reducing agent. Remember these two terms. Okay, so now out of this, which is strong reducing agent? Lithium. After that potassium, after that calcium, after that sodium, magnesium, aluminium, like that. So as we move upside, their tendency to act as strong reducing agent decreases. It is purely based on these values. More negative reduction potential value means it is stronger reducing agent. Okay, more positive reduction potential values means it is stronger oxidizing agent. That's it. These are the two statements. Please write it in your notes, that what is that? More negative reduction potential value means, it is stronger reducing agent. More positive reduction potential value means stronger oxidizing agent. That's it. Hope it is clear. So be clear with these terminologies, because there are few questions purely asked on these statements only. Okay, now let us move further. Now tell me, we need to calculate standard electrode potential values for, see, the E naught cell, electrode potential value, EMF of the cell. That cell is constructed using zinc and silver. Okay, so we need to calculate the EMF of that cell. So since in order to make the construction of electrochemical cell, we required anode compartment, cathode compartment now. So which is to be taken in anode, which is to be taken in cathode? Tell me here. So tell me here, see, the one which is having more reduction potential value, see, both species are undergoing reduction only. Zinc plus 2 converting into zinc means what? It is reduction only, na? So silver plus converting into silver atom, that is also what? Plus is converting into 0, it means reduce, na? That is also reduction only. So the reduction potential values are mentioned here. Standard reduction potential values are mentioned. So greater the value of greater the reduction potential value, the easier it will undergo reduction, the others should undergo oxidation. Which is having more reduction value? So this silver is having reduction value, na? So you should consider these in the cathode, because more reduction potential value, so that will undergoes reduction. So reduction happens in which compartment? Cathode. So now zinc will be considered in anode. So what happens to zinc? Zinc undergoes oxidation. This is what you need to understand. Okay, so now since both are given in reduction potential values, so you need to take the formula in terms of reduction potential value. That what is that? E naught cathode minus E naught anode. Okay, so E naught means that is a terms we are using for indication of reduction potential values only in standard condition. Okay, now how we got this formula? If you have that confusion, look here. See, E naught cell is equals to oxidation takes place in anode, na? So you should write E naught oxidation in anode plus E naught in reduction takes place in cathode, na? E naught reduction in takes place in cathode, na? Write cathode. Okay, reduction takes place in cathode. Like this you need to write first. Okay, after writing this, if you observe here, see, this should be taken as oxidation potential, but value is given in reduction potential, right? So what is the relation between oxidation potential and reduction potential? E naught oxidation equals to negative of E naught reduction. That's it now. So I wanted to take here also reduction potential values in terms of at the anode also. So instead of writing E naught oxidation, I am writing minus of E naught reduction. So I am writing minus E naught reduction at anode plus E naught reduction at cathode. Okay, very easy topic here. Do not make it too much complicated. Just listen here. So E naught reduction at anode. How much which we should to take at anode? So this is at anode, na? That is negative of negative. So it will be how much? So I am writing E naught reduction. See, cathode minus E naught reduction at anode. So we got this formula, na? Yes. So cathode minus anode. The both values should be placed in terms of reduction potentials only. So what is the reduction potential at cathode they have given? That is 0.8. Okay, minus. What about anode? It is given as minus 0.76. Okay, so what we'll get here? Both are in terms of volts. Okay, so now how much we'll get? So it is 6. 80 means 6. So it will be 15. So 1.56 volt plus 1.56 volts is the EMF of this cell. E naught of this cell is how much? Plus 1.56. Hope it is clear. Now if you have any confusion, please feel free to ask us. Okay, so now let us move further and let us understand few more questions here. So we have first option here, that will be our answer. Okay, so let's move further. Now tell me, what is a half cell? See, the two half cell reactions are given. So will you give a try to calculate this EMF of this cell? E naught of this cell I want in the comment box. Anyone from live session can answer this question. What is the EMF of this cell? E naught of this cell. How can we calculate? Yes, look at here. E naught of reduction potentials are given. So which is having more reduction potential value out of these two? See, this value is greater number, na? So it means silver will undergo reduction. So it means this process, reduction process, silver plus converts into silver. So this happens at what? See, since reduction potential for this is more, so this will take place at cathode. Okay, and this should be taken at anode. That's it. Okay, so E naught cell equals to E naught cathode minus E naught anode, right? So what is the reduction potential for cathode? So cathode is this one, a silver. So reduction potential is given as 0.80 minus anode is given as at anode reduction potential value is given as minus 0.13. That's it. So how much we will get? So it is also 391 0.93, that is plus 0.93 volts. Hope it is also clear, right? So if it is also clear, just click on the like button, right? Let us move further. Yes, let us move further. Yes, so let us take one more question. So just take this question and try to arrange or try to give which is having strong reducing capacity, which is strong reducing agent out of these given 4 options. See, their reduction potential values are given. Standard reduction potential values are given for lithium, zinc, hydrogen, this one. So tell me which is strong reducing agent out of the given 4 options based on the values. Very, very easy. I am expecting answer from someone in the comment box. From live session, yes guys, give a try. Do not feel scary to answer in the live chat. You can give your own answer based on your understanding. That's enough. Yes. Yeah. So what we can do here is, what I told you by showing you this this table. See, even I can give you some trick also to remember this. So what is the trick you have? See, I can say just try to read these terms like in a fast manner. Lig basar, like lig basar, kana, mag, almanjan, coffee, koni, sun, pub. Like that, if you read, you will get a like a rhyming of words, rhyming of these letters. Like that, based on that, you can remember the order, which is strong reducing agent, which is strong oxidizing agent, or other ways, make a small statement like we used to follow this, little kid cannot offer, like this. So we used to make a rhyming of it. Okay, like this, we used to make our own sentence and own mnemonic to remember all these terms. Okay, so I suggest you to do the same thing. Okay, so if you are really struggling to remember this order, so in the next session I will make a trick on this, just follow us. Okay, so now let us do this. See, based on this value, see, more negative value, what I told you, more negative reduction potential value, stronger is its oxidizing nature, I mean reducing nature. It will undergo oxidation and reduces others. Means which is strong reducing agent, the one which is having more negative reduction potential value or more positive oxidation potential value is considered to be strong reducing agent. So here, which one is having more negative value? That is lithium. So here also, if you consider the question, see here, which is having more negative reduction potential value. So more negative reduction potential value is this first one is a more negative. So more negative is corresponds to the first one here. So lithium is having more negative reduction potential value now. So that will be what? That will be act as strong reducing agent. Hope it is clear, right? Which is strong reducing agent? This is lithium is a strong reducing agent, right? Hope it is clear. Now let us move further. Now I am expecting an answer, the order of reducing nature of these species based on these values. Just give more negative, stronger reducing agent. After that, which species comes? Like that, give me the order in the comment box. For this fourth option I told you now I am asking you to arrange them in the order of reducing nature. Okay, so let us move further. So here you tell me, can a solution of 1 molar copper sulfate solution to be stored in a vessel made up of nickel? So tell me, can a solution of 1 molar copper sulfate solution, copper sulfate, to be stored in a vessel made up of nickel? See, this is a nickel vessel. This is one of the frequently standardized question that is used to understand the concept properly. So this is what? Nickel vessel. So in this what they stored? Copper sulfate solution. So is this recommended or is this feasible or is this proper way to store? Can we store or not? That is what they are asking. So look at their standard reduction potential values. So which is having more reduction potential value? See, here it is having negative reduction potential value. So copper is having positive reduction potential value. So since copper is having positive reduction potential value, so copper will easily undergoes reduction and it will undergoes reduction and oxidizes nickel, right? Since since copper plus 2 is placed, this copper plus 2 solution is placed in this nickel vessel. So copper plus 2 having more reduction potential value, therefore copper undergoes reduction by taking 2 electrons from this nickel, therefore nickel undergoes, by losing 2 electron, nickel undergoes oxidation and forms nickel plus 2. So what it is doing, copper sulfate solution is damaging nickel by making it to undergo oxidation, right? Therefore the vessel get damaged and the solution comes out of it. Therefore what we can conclude, we cannot store copper sulfate solution in this nickel vessel. Why we cannot store? Because copper plus 2 converting into copper, it means its reduction potential value is high, therefore copper plus 2 from the copper sulfate solution easily converts into copper by taking 2 electrons from this nickel, right? It means if it is take 2 electron from nickel, the nickel metal converts into nickel ions, it means this metal whatever the metal, this vessel which is made up of nickel getting damaged. So this is what you need to understand. Okay, so therefore it is not recommended to store copper sulfate solution in the nickel vessel. Hope it is also clear. Now I have a question for you. The question is about can we store copper sulfate solution in zinc vessel? So this is my question for you. Okay, and one more question number 1 and question number 2, just comment me, just write your answer in the comment box, I will be looking into it. Okay, so now can we store zinc sulfate solution in copper vessel? So how can we answer these questions? Just by looking at the reduction potential values we can answer. If the standard reduction potential value of copper plus 2 is more, so what happens? Copper plus 2 when compared with the zinc, so copper plus 2 undergoes reduction and zinc will get oxidized, therefore zinc will get damaged. Like this, you just understand these two questions and tell me your answer in the comment box. Okay, feel free to discuss. Okay, let us move further. These two answers I am expecting from you in the comment box. Feel free to answer. Okay, next let us move here. So which of the reaction is not possible? In the 4 reactions, which is not possible they are asking. Look here, iron converting into iron plus 2, 0 changing into plus 2. So what is this process? Oxidation, right? So now here H plus converting into H2, it is undergoing reduction. So now this is also based on what? The reduction potential values only. So now since which is not possible they are saying. So first one I am saying it is possible. Why it is possible? If you look at their values, so reduction potential value of iron is negative, Fe plus 2 to Fe is negative. It means oxidation potential of iron will be positive now, positive. So iron easily undergoes, since oxidation potential value of iron is positive, whereas H plus hydrogen is considered to be 0. Okay, so these values, reduction and oxidation potential of hydrogen is 0. So therefore the oxidation potential value of iron is more, therefore iron easily undergoes oxidation. So converting iron to iron plus 2 is a spontaneous process. So this is possible. Like this you need to understand. So even if you don't know the values, there is no issue, but you need to know whether it is having positive value, negative value or comparative values with the other elements. For example, if I compare, here we are comparing iron with hydrogen. So whether compared to hydrogen is 0. Now whether iron is having positive reduction potential or negative reduction potential. Like this, if you know that, you can have comparison and you will get that. Amit, this is for NEET 2026 session. So I hope you are following the class, right? Next, if you compare with this copper and silver. So now copper and silver, if you look, so here in this reduction table, look at here. So where do we have this? Copper and silver. See, copper will be having positive and silver is also having positive. See, Silver is at the top here. We have this much. Okay, let me show you for the copper first. Silver and copper, right? See here, silver and copper if you consider. So see, copper is how much? Plus 3.4. Okay, so like this, if you look at their values, so silver, if you see, minus 0 plus 0.8 and copper is having plus 3.4. These are the reduction potential values of silver and copper. So now just even not, it is not necessary to remember the values all the time. Just by knowing the order which is having strong reduction potential value, more reduction potential value, that will undergo reduction and less one will undergo oxidation. So silver is having more reduction potential value, so it will be undergoing reduction. So based on this, now you can answer this question. Where is that? So what happened? Silver is undergoing plus 1 to, it is converting from plus 1 to 0. It means this is reduction only, na? Yes. Now silver can spontaneously undergo to the reduction when we reacted with copper. So it means this process is also feasible, this is also feasible. It means those are possible reactions. Okay, they are asking about not possible. Okay, now look at this. See, I told you what is the oxidizing power of fluorine, chlorine, bromine? F2 more than, Br2 more than, I2 like F2 like this I have told you now. So which is more? First F2, after this Cl2 and Br2 and I2 I told you. So whenever this is there, see here we have in the question they are asking about Br, KBr and I2. So which is having more like oxidizing power? So Br2 is having more oxidizing power. See, Br2 oxidizes I and converts into Br minus. It means Br will stays in Br minus form, not in Br2 form when we compare with the I2. It means this reaction is non-spontaneous. So it means you need to choose third option as our answer. Okay, so this is how you need to make it. Okay, now tell me, can I displace? So you can write the displacement reactions also using this. So for example, displacement reactions means, for example, here I have NaCl plus Br2 will undergo NaBr plus Cl2 formation. Is this reaction is feasible or not? Will it be spontaneous or not? So they will give like this. Even in advanced exam also you can see a question like this. This is very basic displacement reaction. You will be studying this from even 10th class onwards. Okay, so how can you answer this kind of question? Just following this order, this oxidizing capacity order. Okay, strong oxidation, weak like lower, higher values we have seen now. Based on that we have given this order. So from that you tell me which is feasible reaction, NaBr and Cl2. So which is possible here? NaCl plus Br2. Out of these two reactions, which is possible? So tell me. See, we know oxidizing capacity of Cl2 is more than Br2. So it means which will be undergoes oxidation. See, Br2 having more oxidizing power, no? So Br2 Cl2 having more oxidizing power, no? So this Cl2 oxidizes Br minus to respect to Br2, but not vice versa. So it means this is not possible. This is the only possible reaction as it is having more capacity here, right? So second reaction is possible, first reaction is not possible, or I can say this is feasible, this is not feasible or non-spontaneous. Like this you need to answer. Hope it is also clear. Now let us look one more question. Yes, yes. So here which of the following is the strongest oxidizing agent? Which one of the following is strongest oxidizing agent? Tell me which is strongest oxidizing agent out of these four options. So what I told you, greater the oxidation potential, more oxidation potential should be more positive oxidation potential. Okay, so that should be considered as that will undergoes oxidation and reduces others, I told you, right? So that will be considered reduces others means that it will be reducing agent. So here more reduction potential, more positive reduction potential. So it will be undergoes reduction and oxidizes others. So it means reduction potential value should be more positive, that should be act as strong oxidizing agent, strong oxidizing agent. So which is having more reduction potential value, see BrO3 minus means plus 5 is converting into minus, it means this is reduction only. Here Fe plus 3 to plus 2, that is also reduction, like that. So the values given here is reduction potential values only, right? So more reduction potential value, stronger is the oxidizing power it has, stronger oxidizing agent it is. Now tell me, based on that, which is strong oxidizing agent? See, it is third option is having, look here, third option is having more reduction potential value. So more reduction potential value, strong oxidizing nature it has, I told you. So third option is our answer. Hope it is also clear. Now I have a question for you. So arrange these species, these 4 options based on their oxidizing agent order. So which is strong oxidizing agent, after that and which is the least. That like that you give me the order of these 4 options based on their values, based on my explanation. You can easily give that, right? So you can give a try from your side. I am looking into the comment box. Anyone can try in the comment box. Amit, are you there? You can just give a try. Yeah. So now here the 2 tables we have seen now. So where we have fluorine, chlorine, all that orders we have seen, and lithium having more negative, I told you, fluorine having more positive, I have told you. This table I have given now. So you should get one question now. How do we got these values? How we have calculated these values? This might be your question, right? So how might we calculated? Yes. So we calculated these values by connecting these electrodes. For example, if I wanted to calculate for copper electrode, this value we got around, see, for this conversion of copper plus 2 to copper, reduction potential is plus 0.34 we have seen. Okay, so how do we got that value? Yes, we got this value by connecting this copper electrode with the standard hydrogen electrode. So what is the standard hydrogen electrode? So the standard hydrogen electrode, there we will be taking hydrogen gas and platinum rod as a like platinum wire as a electrode there. So these will be considered standard reference electrode. So its reduction potential value or oxidation potential value for that standard hydrogen electrode is considered to be 0. Now comparative to this, to this hydrogen electrode, how much this copper is showing, how much potential this copper is showing. So that is the values we have given here. How much this fluorine is showing, that is the value we have given here. Like that, for all species we have given here in this list and also in this list. So what is that electrode we are saying? That is called as reference electrode. Now what is this? Reference electrode or standard hydrogen electrode. Hope it is clear. Now the remaining things, I mean about this standard hydrogen electrode and the remaining parts we will be continuing in our next session, okay, in the upcoming sessions of this electrochemistry series. Okay, now you will be having physics class, so stay connected with us. And also if you wanted to discuss more about this NEET 2026 preparation or EAPC 2026 preparation, just feel free to contact us to the mobile number provided here, and also you can join our Telegram group through the link given in the description box. Okay, there we will be available. You can feel free to ask your queries there. Okay, so thank you for watching. Stay connected with us. Thank you.